We're going to do as many as we can, then you turn it in.
Sorry.
Where are we starting at?
Oh.
5? Problem number 5. We're starting 15 minutes in. Every time somebody's talking while I'm talking, we're losing time. Number 5 might help to draw the triangle. One thing I will say with Pythagorean theorem, anytime or with any kind of right triangle, and we're going to talk a lot about this as we go, with any kind of right triangle, or any triangle, it doesn't have to be a right triangle, when they give you stuff like the corners, for the rest of the year, probably everything that we do for the rest of the year, the sides across from the corners will be labeled with lowercase letters. So if this corner right here is a big case A or an uppercase A, a capital A, guess what that side is going to be labeled?
Lowercase a.
Little a. If this side is, if this angle is C, guess what that side is going to be labeled?
Lowercase c.
Little c. Now if they do something like PQR as their corners, then it's going to be the same thing. Little p, little q, little r, so on and so on. But the capital letter and the side across from it, the little letter. So in this case, what'd they tell us this time?
A equals 6.4.
So let's go ahead and label this. What do we know about the three corners? What are they going to be labeled? A, B, and C. So that's A. Which one's got to be the C? The right angle. That'll always be that way. So where's A at? Left, right, top, bottom, what?
Top.
Bottom.
Well, yeah, the base.
Bottom. So 6.4 goes there. Then what?
And then the
12
C
goes-
equals 12.
Left or right?
The left c.
Left.
Yeah.
And then little c is what we don't know, right?
Yep.
So when we set up Pythagorean theorem, a squared plus b squared equals
C
squared.
c squared. What's our a?
A is 6.4.
Does it matter which one's a and which one's b?
No.
Not
That's
really.
12.
And that equals c squared. When you're just looking for the hypotenuse, don't make these harder than they are. You're just going to grab your calculator,
149.76.
type all of that in. That didn't sound right.
I got 184.
Just type it all in just like it is.
30.
Oh, my calculator.
184.96. Anybody else get that? Yes, no, maybe?
Yes.
Then what do we do with that?
Oh, yeah.
Take the square root.
Then you take the square root.
13.6.
13.6. What should always be true about, if we're looking for the hypotenuse, what should always be true about it?
It should always be bigger than the other side.
Should be bigger than the other two. Is this bigger than the other two?
Oh yeah.
Yeah. Next one, what are we doing next?
6.
6.
Same one.
Same setup. Do I need to draw the picture again?
No. So we do 2.1 squared plus 7.2 squared
Equals what?
56.25. And then you square root that, and that equals 7.9.
7.9. Does that make sense for it to be 7.9?
No,
5.
7.5?
Yeah.
7.5, sorry.
I think that looks about right.
Does that make sense?
It's bigger than the other two.
Bigger than the other two?
Do you want to do on the back?
I don't care.
Number 20.
Problem 20. Whenever you're doing Pythagorean theorem with right triangles, know which side you're looking for. Does that say 6.5?
Yeah.
And this is x over here.
Yeah.
Are we looking for a leg or the hypotenuse?
The hypotenuse.
The hypotenuse. So we're going to do it the exact same way that we just got done doing those last two. So tell me how to set it up.
2.7 squared plus 6.5 squared. And that equals 49.54.
49 point what?
54.
54. Then what?
And then you square root that, and that will be 7.0.
7 point what?
I got 7.03.
03?
3.8. 4.4.
7.04.
Can't you do like the square root over like 7.2 square?
You can if you want, if you figure it out, just make sure. I don't like telling it that way because one calculator does one thing, one calculator does another. And I guarantee if we did it that way, that probably about half of the people in here are gonna get some answer like 13.5 or 45.6 or something like that.
Mine's a really nice tie.
Because the calculator doesn't completely understand everything. So if you don't type it in exactly right, so if your calculator works out that way, then that's fine. Next one, what are we doing next?
16.
Oh, we get 16. That sounds good.
That's a leg one.
Finding the leg.
What's that say, 3.9?
3.9 and then the hypotenuse.
11.
11?
Yeah. Then we're wanting to find out.
So how am I gonna set this one up?
Would you do like 3.9 squared minus 11 squared?
Now.
Backward.
Be careful, just set it up. This is where you guys get yourselves in trouble because
11.
you were doing this one and you were not actually setting it up every time. And that's fine, but when you get to something that's not exactly like this, then you get lost. So you should set it up the way we were setting it up at the beginning. So it's 3.9 squared plus what?
11 squared.
Plus x.
Oh, I get what you mean now.
Equals what?
11
Just 11?
squared.
Now, if you want, I know you've had teachers that probably taught you this in the past, and those teachers probably told you to just go ahead and move this to the other side. The way I'm hearing you guys tell me, they're saying before you square it, just move it to the other side right now. So we end up with x squared equals 11 squared minus 3.9 squared. Then you can sort of do it the way that you've been doing all of those others, just by punching it into your calculator. What's it come out to be?
I did it.
10.3.
What is it?
10.3.
Anybody else get 10.3?
Yeah.
Does it make sense for it to be 10.3?
Yeah, it does.
How? Explain to me.
It's smaller than the hypotenuse.
Alright, so it's one of the legs, so it should be less than 11. If it's not less than 11, then we messed up somewhere.
Do you want to do 18?
18? Without me drawing the picture, let's just set it up. Do we know what are the legs?
9.7.
9.7 squared. What's the other leg?
We need to find that.
So what is it?
X.
Squared equals, what's the hypotenuse?
13.3.
13.3. So if we move that 9.7 over squared over to that side, it's going to be x squared. Sorry, my pen quit working. X squared equals. Oops, I forgot the squared up there. 13.3 squared minus 9.7 squared. And again, if you're Michael and you want to stick, you're going to take the square root of that. You want to stick it all into your calculator. I'm not going to teach it that way because
9.1.
one calculator is different than every other one. And as soon as I got into this in my first class today, I said, all right, if you have the big calculators, you type this in. If you have the little calculators, you type this in. And of course, right after I said that, Where's the math button on my calculator? This is what Ethan O up here says. Where's the math button on my calculator? You don't have a math button on your calculator. The big calculators have a math button.
Said
The
they're
little
all math
calculators
buttons.
don't. So the person wasn't listening when I said, little calculator, you do this.
They're all math buttons.
That was a good answer. What'd you come up with?
9.1.
Does that make sense for it to be 9.1?
Yeah.
So one of the legs should be less than 13.3. Next question.
I got all the ones I wanted, John. Anyone else?
21. We've got a couple minutes left. 21. We looking for a leg or a hypotenuse here?
21. We're looking for a leg.
So tell me how to set it up.
5.3 squared.
I know it just kills Mason at Ebersole saying to write it out this way every time. Are you going to miss the problems if you write out this little bit every time? Then you're going to know what process to do. All right?
Plus x equals 7.2 squared. Oh, x squared. My bad.
So we get 7.2 squared minus 5.3 squared.
Yeah.
If nothing else, when we take a test over this stuff, you write that out, you know you're going to get partial credit, even if you mess up. What's that leave you with? What is it? 79.93. Anybody else get that?
Yeah.
What were we looking for?
The leg.
Is this our answer then?
No, we need a square root. of-
Oh, we still got to take the what?
I got 4.9.
I got 8.
I got 4.9.
So we got 4.9, we got 8.9. What were we looking for again?
Not the leg.
A leg?
Yeah, there's
so
no
that's
way
the
it could be 8.9 because the
8.9
hypotenuse is 7.2.
8.9 is bigger than the hypotenuse, so is that going to work?
No.
Ah.
So what's our answer?
4.9.
Because we set it up.
Let me see if I care. You're wrong.
It's, you got minus there. See? That's what I'm saying. If we set it up the same, starting off every time, every single time you start off the problem the same way, just writing out that equation. Then you'll know if you're just adding or subtracting or what you're doing. Next one. Might have time for one more.
Dude, we could do 19. Looking for a hypotenuse. .2 squared plus 9.2 squared equals
Just X?
squared.
Again, I know it's killing all of you to write down that starting equation there, but it's just so difficult.
So difficult. That's the way to do it.
What do we end up with?
14.2. No, that's
10.6. Anybody else get that?
Yeah.
Is it alright for it to be 10.6?
Yeah. It's bigger than the legs.
It's bigger than the two legs, so that would make sense. 10.8? Make sure your name's on them. You're going to lay them right here. If you didn't grab the notes, make sure you grab them while you're up there.
Christ, what the heck?
I said 10.8. 10.8. He just looked away. Like that was how the conversation's supposed to be.
10.8?
No.
I think you were supposed to say something more.
I don't know. Not my problem.
need you.
Center your
I
hand.
need you. I need you.
Start filling in what you need to fill in on this. We got a lot of notes to cover. So you're gonna wanna hurry and write. We're gonna go through it quickly.
I'm switching sides.
I agree.
It changed.
It's the same. It's the same. It's only class it doesn't change. Class is the same.
No, I was talking about the
Yeah, you dingus.
Whenever I write supplementary, but just the two P's, like make it abbreviated, it sounds so cool in my head. It's like so.
If you do it on the computer, it won't abbreviate it that way. It corrects it and just puts SUP. So I'm gonna go back and fix it all the time. As a matter of fact, there might be a couple of them on here that I didn't go back and fix, because I forget. Parallelogram. Out to the side, you might want to draw a picture. A normal parallelogram, the one that you think of as a parallelogram, usually looks something like this. It's sort of a tilted rectangle. That's a parallelogram. In a parallelogram, these are all the properties of a parallelogram. In a parallelogram, opposite sides are, what's this symbol mean? Parallel.
Oh, so, geez.
So just these two sides are parallel?
No.
No.
The other pair of sides are parallel also. Alright? So both pairs of opposite sides are parallel. Opposite sides are also what to each other? So if this side's 10, what's this side down here? 10, and so on and so on. Opposite angles are congruent. So if I told you this angle here is 72 degrees, we'll call that A, B, C, and D. Which other angle do you know?
Is it D?
D is what?
72.
72. Now, you also know the other two angles because of this next rule. The next rule says that consecutive angles have to be supplementary. What's supplementary mean?
180.
You might want to write that down there just to refresh your memory. Supplementary angles is 180.
So 180.
So, could we find angle A?
Yes.
Yes.
How?
180 minus 72.
What's that give us?
108.
So angle A is 108. Well, if angle A is 108, what else do we know?
C is 108.
C is 108. So they tell us a little bit of information. We know a lot of stuff about a parallelogram. Diagonals bisect each other. I'm going to draw another. That's horrible, but these diagonals, if you draw in the two diagonals for them, they bisect each other. So this segment's congruent to that segment's congruent to that segment. Here's where you got to be careful, and I usually have my little thing out here and it shows you, but I don't have it right now. I might look for it here in a minute. Are the diagonals in a parallelogram equal to each other?
No.
All right, because the way it's tilted,
Someone just say yeah.
which one of these is going to be longer?
The one on the far left.
The one you just did.
The one I'm just tracing,
Yeah.
right? It's going to be longer because it's stretched out that way. So this one's going to be shorter than that one. In a parallelogram, that works. They're not the same. So are all four of these parts the same?
No.
No. These two parts are the same. These two parts are the same. Sum of the interior angles. We did this last chapter. The sum of the interior angles
I was having a train.
is always equal to 360 because it's got four sides. So let's go back up here. If we added all these up, what should they add up to?
360.
Do they?
Let's find out. It looks like it, yeah. Yeah.
Yeah. All right. So any four-sided figure, all these four-sided figures that we do down through here, for the next bunch, the four angles are always going to add up to 360 degrees. Next one, a rectangle. Fill in what you need to fill in on that. And this is another thing that my computer does. I fixed all this so it didn't look like this, and then I switched it back anyway. A rectangle. What's the one main property for a rectangle?
It has 4 right angles.
4 right angles. So if, for it to be a rectangle, every angle has to be a right angle. Now, it also is a parallelogram. So if it's a parallelogram, guess what other properties it has?
The diagonals bisect each other.
All the properties that you just wrote down a minute ago. All those properties for a parallelogram work for a rectangle. So you might want to write that down here. All parallelogram properties. So everything that works for a parallelogram works for a rectangle. Opposite angles are congruent. Consecutive angles add up to 180. So on, so on, so on. Because a rectangle is a what? A parallelogram. All right? Does that mean all parallelograms are rectangles?
No.
No, but all rectangles are parallelograms. Now, the one thing that changes from a parallelogram, when I draw in the diagonals, what do you know is true about those two diagonals?
Maybe right in the middle.
If I start walking from here and I walk to there, and Michael starts walking here and he walks to there, who walked farther?
Neither. Both of you.
We both walk the same.
Probably gonna
So
run.
unlike a parallelogram, remember in a parallelogram, we just said, is this distance the same as that distance?
No.
But in a rectangle, those two distances are the same. So what's true about all 4 of these little parts here?
They're congruent.
They're all 4 congruent. All right, so all 4 of those little parts are congruent to each other in a rectangle.
Finding a diagonal and putting a point where they intersect, is that the middle of the?
You don't really like to say middle of a shape. A circle has a middle. You don't really like to say that either. Because
Midpoint.
it's the midpoint of those segments, but we don't, there's not really a middle of a shape. Most shapes.
There's a word for it, I can't.
There, right. There's the middle of a circle, and the reason we call it the middle is because what do you know about the distance from that point to the edge of the circle?
It's always gonna be the same.
It's always the same. Now, if I take here, the reason we don't want to call it the middle, the reason that mathematically that doesn't really work, does it matter if I walk to anywhere out here, is all those distances going to be the same?
No.
So we don't want to call it the middle, or the center point. All right, that doesn't really work. Does that make sense? To prove something is a rectangle, you can prove it's a parallelogram with 1 right angle. Now, we said it has 4 right angles. How come just 1?
I thought the rest of them would be.
All right, if we have this shape and we're trying to prove it's a rectangle, and we say, okay, we know it's a parallelogram, and we know that this is a right angle, well, if that's a right angle, what's this angle down here have to be?
Right angle.
A right angle. And then we know that these 2 angles are consecutive, so they have to add up to 180, so what's this one got to be?
90.
And then this one's got to be, so it works out that if you know one of them's a right angle,
They're all right.
they're all going to end up being right angles if it's a parallelogram. Prove it's a parallelogram and prove that the diagonals are congruent. So if this distance is the same as that distance, and we know it's a parallelogram, then it has to be a rectangle. A rhombus. Anybody know what a rhombus looks like?
It's kind of like a diamond.
Sort of. We don't want to call it a diamond because the diamond is not a shape.
Tilted square.
It's a tilted square. Still with me, Ethan O?
Yeah.
Set up.
Trying to find the math button.
So it's sort of a tilted square. So a rhombus is a parallelogram, but what's true about it? What do you know about all these sides?
They're congruent.
They're all congruent. So it's a parallelogram where all four sides are congruent.
None of the angles are 90 degrees.
This time, none of the angles are if it's just a rhombus. If all four sides were congruent and it had right angles, what shape would it be? Square, and that's what we're going to go to next. Now, one other property that a rhombus has that parallelograms or rectangles didn't have, or these two properties, if I draw in this diagonal, guess what it does to that angle right there? It bisects. Rectangles and parallelograms, that doesn't work. If those two are the same, guess what's always also true about these two down here? They're the
They're
same. So if I told you that was 40 degrees, what's this angle over here? 40. What's this one over here? 40. What's this one over here? What's this whole angle here?
80.
80. Could we find this angle up here then?
Yeah.
It's 100, because this angle and this angle have to add up to 180. Now my picture doesn't look right, I didn't draw it that way, but that's what it'd have to be. And then we could find this angle. How much is this angle? 100. What if I drew in that diagonal? What's this angle right here? Be careful. How much was that whole thing?
80.
This whole thing was how much?
100.
100, so each, that's going to be 50. That's going to be 50, 50, and 50. All right? The other thing with the diagonals in a rhombus, if I could draw a good one. When you draw the diagonals in, all these angles here in the middle, guess what they are?
90 degrees.
They're all 90 degrees. They're all right angles. All right? So in a rhombus, the diagonals are actually perpendicular to each other. Doesn't work in a parallelogram or a rectangle, but in a rhombus it does. And this should be, so diagonals, that upside down T should be there instead of way over here all by itself. The computer would quit. I just switched it back last week when I was looking at this, and for whatever reason the computer doesn't like it that way. Or I could be wrong. Maybe I know I switched it back. Maybe the computer's fine with it now, and I pulled up the wrong PowerPoint. I pulled up the old one instead of the one that I switched to. I didn't think so. Yeah, it's probably I probably messed up something. I should. A square. For a shape to be a square, it's got to be a parallelogram, it's got to be a rectangle, and it's got to be a rhombus. We'll probably go back over this at some point, but if we start off with a quadrilateral, from a quadrilateral, the next shape you could have is a parallelogram. This is like a family tree. From a parallelogram, the shape could be a what? What do we go to next after a parallelogram? A rectangle. Now, did it have to be a rectangle? No, it could have also been a what? A rhombus. Once we had, maybe it was a rectangle, maybe it was a rhombus, it could also be a what?
Square.
A square. Now, to be a square, it has to be both of those two. And not only is it a rectangle and a rhombus, but it's also a parallelogram and it's also a
I
quadrilateral.
think you did pull up the old PowerPoint, because on our paper it's the O is there.
It's got it. Now, some new books will do this, right in here, and we're gonna talk about this here in a minute. Instead of being a space there, they'll have another shape in between those two.
Between a quadrilateral and a parallelogram.
In between a quadrilateral and a parallelogram. So what's the key property of a parallelogram?
All equal. No.
Opposite sides or what?
Parallel. Parallel.
Parallel. What's the key property of a rectangle? You told me when I asked you.
4 angles.
4 right angles. What's the key property of a rhombus?
94 right
4 perpendicular.
sides. 4 congruent angles. Sides.
4 congruent sides. All the sides are the same. Now, a square has 2 key properties. What are they?
4 right angles.
And then 4
4
congruent sides.
congruent sides.
4 right angles, 4 congruent sides.
It's a trapezoid.
Now, what do you think might go in here then?
Right? Trapezoid.
Trapezoid. Because, does anybody know what a trapezoid is? What's it have?
Parallel sides.
All the sides, or opposite sides are parallel just like this?
No.
Instead of having both pairs of opposite sides being parallel, it has one pair.
Okay.
And I got in an argument, went to some math meeting a long time ago, and not really an argument, because I just didn't think it was worth my time to argue about it, but the guy said, oh, a trapezoid ought to be in there, because my thought is a trapezoid ought to be like its own branch over here. And that's the way it's always been, all right, because it's different than the others. But the new definition that they're giving to a trapezoid, and the only reason that I've sort of changed is because the definition that all the rest of the world gives to a trapezoid is it has at least one pair of parallel sides.
Mine only has 1.
So our definition that I always learned was it had exactly one pair. The rest of the world says it has at least one pair.
It wouldn't be that if it had more.
Well, then we could say it is a
Parallelogram.
parallelogram. So all parallelograms are trapezoids, but not all trapezoids are parallelograms, just like with rectangles and squares and all the other stuff. So it sort of makes sense for it to be there. A trapezoid, what you normally think of as a trapezoid looks like this. These 2 sides are parallel,
The other 2 are not.
and the other 2 are not. And these other 2 are called, and you might want to draw this picture. Sorry, I'm not sure why I'm doing that with the black pen instead of the red one. The other 2 sides that are not parallel are called the legs. And this is base 1, and this is base 2. And it doesn't matter which one's 1 and which one's 2. You just have 2 different bases. But you gotta, just like with an isosceles triangle, you gotta know the parts of a trapezoid. This says the angles surrounding a leg are supplementary. So that means this angle and this angle have to add up to 180. This
Okay.
angle and this angle have to add up to 180. Does that mean that this one and this one have to add up to 180? No. These 2 and those 2. What do we know about all 4 angles again? They're all going to add up to
360.
360. All these 4-sided shapes, the angles always add up to 360 degrees. An isosceles trapezoid. Anybody have a guess what an isosceles trapezoid is before you start writing it down?
2 sides are congruent.
Which 2 sides does it have to be? The legs.
Yes.
So the legs are congruent. This leg's congruent to that leg. These two are parallel, those are the bases. Bases are parallel, the legs are congruent. And I'm also going to mark this in an isosceles trapezoid. This angle is always congruent to that angle. This angle is congruent to that angle. If you can draw that picture right there, that explains everything you need to know about an isosceles trapezoid. Now, some other trapezoids, if you don't know what another trapezoid might look like, a trapezoid could look like this. As long as those two sides are parallel, that's still a trapezoid. It's just not an isosceles trapezoid. Also, in an isosceles trapezoid, one other thing, when you draw in the diagonals, they don't bisect each other.
But are they congruent?
They are the same length as each other,
Okay.
right? And you can probably look at it and see, if you look at this picture, what do you think's true about these top two parts? They're the same, and what's true about these bottom two parts?
They're the same.
They're the same. Now, they don't bisect each other, but the top two parts are the same, the bottom two parts are the same. That's in an isosceles trapezoid. Doesn't work for just any other trapezoid. The last one, a kite. You might want to write this down. Don't call it a diamond. No such shape as a diamond.
Is it kind of like how this one says shape and oval?
All right.
That's an ellipse.
Even though there was one of my stupid things around here that
It said oval.
says oval on it, because I marked it out. Because mathematically, it's not called an oval.
Why is that?
Oval doesn't, an ellipse, when you have an ellipse has two radii.
Two, yeah.
That radius and the radius going down is always the same. Then the radius going over this way is always the same. If it's an oval might be like an egg shape. Where it's, and there's really no center to it. Alright. So an oval is not a actual mathematical shape, it's just a,
It's the same thing.
I thought it was like
No.
a snap.
I can't draw it, Mike, I'm sorry. Think about an egg.
Right.
Jump really
Okay.
fast.
An egg.
An egg, when you look at an egg, it's got a fat top, right? And it gets skinnier at the bottom. An oval has to be the same on both. So if the egg was the same here as it is here, then that's an ellipse, and that's what we deal with. But if it's an egg shape, where it has a fat top, and then it comes down to a skinny bottom, we can't do anything mathematically with that. A kite. Kite's a little different than the others. And if we go back to our family tree here, kite's like the oddball. So it is on its own branch out here. With the kite, what has to be true about a kite is there has to be some place where you can cut it and you get two congruent sides here two congruent sides there. Alright? So these two consecutive sides, these two sides that are hooked together have to be the same. These two sides that are hooked together have to be the same. Okay? A diamond, the reason we don't want diamond as a shape is because if I draw a baseball diamond, what actual shape is it? It's a square. Alright? So we don't want to get diamond, kite, square all confused. So this is a kite, then there's a difference for a square.
There is no diamond.
Alright, there is no diamond.
Why do we call? Never mind.
Why? Never mind.
So if we have this, if we have a kite, any time we have a kite, I can't draw them very well. These two sides are going to be congruent. These two sides are going to be congruent. If you draw in the diagonals, what they have is they have like half properties. So a kite has half properties, and we're going to talk about them, but we won't deal with them a whole lot. If we draw in this diagonal and we draw in the other diagonal, this diagonal bisects the two angles. This diagonal does not. This diagonal bisects this diagonal, so these two segments are congruent, but the other one's not being bisected. And that's why they're called half properties. They're half properties because they do it to half the shape and not the other half. Does that make sense? And the other thing that we know in this whole angle, put 3 marks on it, is congruent to that whole angle, whereas this top angle and this bottom angle are not congruent to each other. How often do you see a kite?
Not very often.
Not as often as squares, rectangles, and stuff like that, right? So kites aren't as, we don't use them as much. Oh, did I forget to put that in there? Oh, this one's
Yeah.
got motion on it, doesn't it? Hold on, let me do this. Erase all the ink on this. That's all the stuff that I just said there that I put motion in it for some reason. And yeah, I know I did pull up the wrong PowerPoint because I remember making my segment, making my segment symbols darker here because I had them real small. So fill in what you need to fill in. I already went over it. The one thing that kite does have that all the other shapes that we've talked about has, all the interior angles add up to 360 degrees. Anytime it's a four-sided shape, the 4 interior angles is going to add up to 360 degrees.
Is there a shape that won't happen? Always
All,
360?
all 4-sided figures. As long as it's a convex shape. If it's concave, where we have something like, let's see, I gotta be able to draw it.
You could just draw a giant plus sign.
So that's got 4 sides,
True.
then the angles aren't gonna add up to 360. But it's a concave quadrilateral, so it's different. It doesn't fit the rules.
That. I don't like that. It's a weird shape.
It's just a mouse cursor. That's all I do. That's all that is.
I got the little stick on the back.
We just
Stick.
did these a few days ago. Just rewrite them again. Those formulas to find the sum of the interior angles of a polygon, the sum of the exterior angles of a polygon, each interior angle of a regular polygon, each exterior angle of a regular polygon. You know, Cameron's gonna throw a fit, cause he goes, God, we wrote them 3 times that other day, Ebersole, why we gotta write them again?
Appreciate it.
Remember back to about 5 or 6 years ago, before they got to me and said, you know, you need to start doing guided notes instead of before. Guess what happened when we
All
came up?
notebook.
You just had to write it all yourself instead of just filling in stuff.
That would take so much longer. How did you get all the materials, or did you just rush them super fast?
Yeah, you just have to write. You can't just sit here and mess around.
Oh, you gave us a little chart?
So that chart, we filled it out on the other set of notes. That's what's next. Just stuck it on there again, so you have it somewhere else. It's already filled in for you. I don't know, it's sort of hard to read, maybe, but I have faith that your guys' eyes are better than mine. Just tells you, like, what's the sum of the interior angles of a hexagon?
Sum of the interior angles of a hexagon?
720 degrees.
720 degrees. How many angles does a hexagon have?
6.
6. So all 6 of those angles got to add up to 720, whatever it is. If it happens to be a regular hexagon, we know each angle is how much?
120.
120 degrees. So on and so on. Perimeters and areas. Yeah, I know this is different because that's probably not on your paper, is it?
No. Nope.
Fill in what you need to fill in on this. We're going to deal with perimeter and area. We dealt with perimeter and area earlier this year, so we're going to go through this sort of quickly, but we're going to talk about some new shapes, find the perimeter and area of some different shapes. Please remember, with your units, if you're doing area, units is always something squared. We talked about that earlier this year, right? It's always square units. Area. Perimeter is always just regular units. So if you were going to walk around the perimeter of the room, you're going to walk so many feet or so many meters. Not meters squared, not anything else. If we're going to lay carpet in the room, then that's when we're dealing with square feet or square meters.
You just do that.
For perimeter, you just,
Add,
and that's what's on the next slide. So area, always square units, and if you wanted to write it, maybe Mason doesn't like the little 2, so if he wanted to write SQ feet, means the same thing. Square feet, square feet. Perimeter, the distance around something, is always just regular units. Perimeter. To find the perimeter, just add up all the sides. No matter what the shape is, whether it's a 4-sided figure, an 8-sided figure, a 10-sided figure, you just add up all the sides. So how do you do a circle?
Isn't it
Radius.
pi or something like
It's got its own formula, right?
that? Yeah.
It doesn't have sides, so it's got its own formula, and we'll talk about that. So perimeter, you just add up all the sides. For area, we're going to go through each of these shapes. For a square, fill in what you need to fill in on this one. Is that on there somewhere?
What says or?
Yes.
But there's no or on here.
Or, where was there an or?
Area
A
equals
equals A squared
S2.
or
Oh, here.
Yeah.
I can't remember what the other one was.
So A equals S squared, or, yeah, I put it on your guys' paper, didn't put it up here. We know a square is also a what?
Rectangle.
So how do you find the area of a rectangle?
Like that way.
So if you don't like this formula, where you take the length of a side squared, just consider it a rectangle and just do the formula for a rectangle. And we could put another or in here, because a square is a rectangle, but a square is also what? Parallelogram. Anybody remember the formula for area of a parallelogram?
Think about that.
If not, then we'll
Something
get
about width
we'll get to it here in a second.
or height.
A rhombus. A rhombus, to find the area of a rhombus, and I would probably change this formula. This is the one that you got there. I would probably change it to this. D1 times D2 divided by 2. It's a little easier sometimes to plug into your calculators. So to find the area of a rhombus, D1 and D2 are the two diagonals. That's a diagonal. That's a diagonal. That's one way to find the area of a rhombus. Another way to find the area of a rhombus, we probably should have did parallelogram first, because we need to know it again. Area of a parallelogram, because a rhombus is a parallelogram, is just base times height. Base times height. So that works for a rhombus also. Or you could use the other one. Depends on what information you're given in the problem. Lots of different ways to find areas of all these different shapes. There's all kinds of different formulas. I'm only giving you a few of them. A rhombus probably has 50 other ways. You know, if you know this information, that information, finding the area. Next one, a kite. Same idea. I'd probably change this into D1 times D2 divided by 2. Notice that's the same formula as what?
Rhombus.
For a rhombus.
So, are rhombuses tight, or is it just like, just happen to be that way?
It just happens to be that way. Some things consider, some things will, like, if we were doing our family tree out here, they would like connect a kite to a rhombus and say it's sort of a offshoot of a rhombus, or a rhombus is an offshoot of a kite. I'd rather keep them separate so that you don't get confused. But it is the same formula. As far as area goes, it's the same formula. How do you find the perimeter of a kite? Add up all the sides. Still nothing. So if this side's 8, that side's got to be 8, this side's 5, that side's 5, you just add all those up to find the perimeter. Oh, the other thing too, I think it said it as a kite, but I didn't mention it. Guess what's true about these 4 angles in here?
They're perpendicular.
They're always perpendicular, they're right angles all the time. So you could use Pythagorean theorem there. Next one, a rectangle. Base times height, or you guys already told me it could also be what? Length times width, either way works. Whichever way you want to call it, whether it's base height, length, width. Should have put these in a better order. That should have probably been one of the first ones.
Rectangle or?
Does it say or?
One times width.
So that's the length times width.
Under rectangle.
You put length times width. Times width.
So this works because, and the next slide's probably parallelogram again, we should have had it first, or one of the first ones. A rectangle is a parallelogram. So either one of those formulas, it means the same thing. It doesn't, most books now have base times height instead of length times width, and they've sort of done away with the length times width because they don't want people to be confused. Next one, a parallelogram, base times height. You've got to know in a parallelogram, this is picture drawn on there for you.
Yeah.
Make sure that you know the height in a parallelogram is always going to go from one side to the other, and it's always going to have a right angle. Just like the height of a triangle, which we'll get to here in a
Will
minute.
it always go from like, one of the?
Corner?
Yeah. well,
Not necessarily. So, because if I have that height, if I do this, that height and this height are going to be the same thing regardless, as long as it's a parallelogram.
Okay. That makes sense.
So the height in a parallelogram is just given, it's always going to have a right angle with it. That's always going to be your height. Sort of looks like an H. The other thing that they might do with a parallelogram, if I can draw it, to give you the height, they might do something like this.
Yeah.
You ever see something like that where they have something outside of the shape?
Yeah, they did have triangles.
Yep. That's the height, and that's the same with a triangle. Okay, sometimes they give you the height outside of it. Regardless, the formula is always base times height. That's my parallelogram. Could we find the area of it with the information I've given you? No. We don't have the height, all right? But we could find the what? The
The
perimeter.
perimeter.
By just adding up all those sides, still just add them all up. Triangle, again, I might change this into, instead of 1/2 times base times height, probably base times height divided by 2. It's easier to plug into the calculator that way. What if they give you a right triangle? What if I give you this right triangle? And I tell you those are the lengths of the sides. Could you find the perimeter?
Yeah.
Just by doing what?
Adding up all this up.
Add them all up, that's pretty easy. Could you find the area?
Yeah.
What's the base?
3,
What's the height?
4.
Now, it doesn't matter which one's the base or the height, but when you're doing a right triangle, the two legs, one's the base, one's the height.
Okay.
So it'd be 3 times 4, and then you gotta divide that by 2.
So is it 6 squared?
6, and whatever our units is. If they don't give you units, then write units squared, because we know we're dealing with area.
Okay.
What would the perimeter be?
Like
12, and it's just regular units. That'd be the perimeter, that would be the area. Is it all right for the perimeter to be bigger than the area?
12. Yeah.
Does it have to be?
No.
So don't think that. A lot of students think that one has to be bigger than the other, and
And that confused me on the test.
it doesn't have to be. This shape, the perimeter is bigger than the area. The next shape, the area might be more than the perimeter.
How is that possible?
Just depends on the shape. So what I always look at, and this might not make a whole lot of sense to you guys, but what I always look at is, if you look at very old houses in the area, does anybody know what shape their floors are?
What houses?
The very old ones. They're
Rectangle.
squares. You know why they made them squares and not rectangles like we do now?
To make it easier math.
It's even.
That's true, but
Oh, to get the square foot.
because of what?
Square foot. To get the perfect amount. Like to tell you how much.
Not to get a perfect amount, because I don't know.
Rough estimate.
Anything such thing as a perfect amount. But a square, if you make something a square, you get the most square footage out of that rather than a rectangle or any other shape. Right? So a square is always going to give you the most. So when they were building houses 200 years ago,
They're just
Square.
perfect
They always made 'em
boxes.
squares because that gave them more footage inside the house. Now, as things moved along, and you probably, if you live outside of,
Why did we change that?
if you live outside of New Paris, every house is a rectangular shape, all those brick ranch houses, you don't get as much square footage. But the reason that they changed is not because Michael wants to live in as much square footage as possible, but it was easier for people who were building them to build them.
So we're just getting lazy? That's terrible. We need square houses again.
And
They live in boxes.
if you look at all the farmhouses around,
They're all skinny and tall.
they're all skinny and tall. The bottom down here is a square, and then if there's anything else added on to them, guess what they added on? Another square.
Really?
So look at them, and when you see that the houses in our area, you
When
have
did they-
a square added to a square, added to another square, added to, and they make like everything's sort of square, and they go up 2 or 3 floors.
They're just making it easy on themselves.
So that always gave you the most. Now, when you get inside the house, if you have a square, it might give you the most, but it doesn't help you out when you gotta split it off and, put a bedroom here and something here. So that's where the rectangles, because then you could have a walkway and a bedroom here. If you look inside your houses, a lot of the bedrooms and the separate rooms, guess what shapes they are?
Squares.
Squares. So there's squares inside
Of a square.
of, most of the new houses are inside of a rectangle, so they put a bunch of squares inside there. I know I was just messing over the weekend. I was, one of my son had moved out, and I was messing with his bedroom, and his bedroom is like 11 by 12. So
Okay.
it's not quite square, but it's really close.
That was a straight line.
Yeah, that is a really straight
All
line.
lines are straight.
Segment.
You might want to change this formula. This is for a trapezoid. A trapezoid.
Jeez.
You might want to change it to that again instead of 1/2 times all that. It's just all that divided by 2. What's H stand for?
Height.
The height. And the height's given the same way in a trapezoid as in a triangle or a parallelogram. It's always going to be given with that right angle. What's the 2 B's stand for?
Base.
The bases. How come there's 2 of them?
Because there's a bottom base and a top base.
All right. Now, you got to be careful. This is a base, this is a base. What's always got to be true about the bases? They always got to be parallel to each other. Make sure you don't pick the other 2 sides, the 2 legs. All right? The bases always have to be parallel to each other. The hardest one,
Regular polygons?
a regular polygon.
Move that big old fat head, Clark Kent.
I would suggest the paper, I'm trying to find mine right now. The packet that you had with all the formulas that we used last time, I told you not to lose, you might get it out.
We're good, Clark Kent. Thank you.
I don't think it's Clark Kent. He doesn't have blood shit.
Doesn't matter. He's got those glasses and that super hot ripped old shirt.
That's what I've been using.
You don't realize that Mason is actually the guy that
Do you need it? It's area equals 1/2 P times A.
So we're gonna cover all these formulas over the next week or 2, a whole bunch of them. Flip to the back of the first page. Hold on. Yeah, let's flip to the back of the first page.
You know, I still have like a lot of notes to put in my binder. Whenever you grade these, do they have to be in perfect order? I can do that. I just need a sheet.
On this shape right here, I think this shape is on your paper, isn't it? You want to label these things. Number one, this has to be a right angle. So draw a right angle box in there. That segment right there is called the apothem. So a new term. Some of you, I'm sure you haven't heard before. The apothem. The apothem goes from the center point of the shape to the midpoint of one of the sides of the shape. That's the apothem.
What does that even mean?
It's just a name, just like Luke.
Okay.
This, when you go from the center to one of the corners, sort of like in a circle, that's called a radius. Sorry, that's really ugly. That's a radius, so write that in. That's a radius. You had it from last time. No, well, you had, the formula packet.
Yeah.
You had it when you took the test last time. So hopefully you got it in there somewhere. Oh, not too late yet. So looking at that, the back of the first page, all we're going to do, and again, you might want to change this formula to P times A divided by 2. P stands for perimeter. A stands for apothem. So you just multiply the perimeter times the apothem, then divide by 2. If you look at the back side, where it says regular polygons, it gives you like 3 different formulas. All right?
Yes.
The top 2, the bottom one's the one that we're using right now. That's the only one you need to know for now because we haven't covered the other stuff yet, but we will. The other 2 are when you know different information. So sometimes you'll know the apothem, sometimes you'll know the radius, sometimes you'll know, whatever, different things. If I told you that this side right here was 3, how could you find the perimeter?
With regular, then they all have to be 4.
3, right?
So each one of these is,
3.
and how would we find the perimeter?
You just add them.
Add them all up.
Okay.
Then they're going to tell you the apothem. And all you do is you add all these up, multiply it by whatever the length of the apothem is, get that answer, and then divide it by 2, and that tells you the area of the polygon.
Oh.
All right? So nothing hard about that formula. It's a new formula. It looks hard. Find the perimeter. Multiply that answer times the apothem, and then divide that total answer by 2. That's the area of the entire shape, of the entire polygon.
How exactly does that work? Like, why is...
Because what it's doing, this formula, what it's doing, I hate to do this to our shape, but has everybody got
Yeah.
that? It's splitting this shape up into a bunch of what?
Triangle?
And all those triangles are the same.
Oh, I see.
All right, so it's splitting all of that shape up into all those triangles. And that apothem is actually the height of each of the triangles. And then the perimeter is actually the base of each triangle all added together. What? Oh, he wants a detention, is that what he said?
Basically, yeah.
Flip back over to the first page real quick.
He wants 2 there.
And there's other formulas on here that we're not gonna, or like ellipse and circle, they're on there. You can find that Notice apparently I didn't know pi, there's a pi symbol on the computer, but I wrote pi instead. Everybody knows that that's the pi symbol in your calculator, right? Apparently I couldn't find the symbol at that point. If you look at a triangle, it's got 1/2 times base times height, but then it's also got this formula, which is called Heron's formula. Heron's formula is that big long square root, and Heron's formula is not as hard as it looks, but to find S, and we'll talk about this more as we go throughout this chapter, to find S, you take the length of each side, add them all up, divide by 2, and that's just the S, and you just plug into that formula. I know it looks hard, it's not. Right? Because you can find S real easy by adding up all the sides and dividing by 2, and then you just plug in the formula and you let your calculator do all the work for you. You flip over to the back page again, an equilateral triangle. What do you know about an equilateral triangle? What's true about an equilateral triangle?
All the sides are equal.
All the sides are equal. So if I told you this side was 10,
The other two sides are 10.
the other two sides are 10. To find the area of this, you see that formula there?
Yeah.
Instead of finding the height and going through all that headache and doing base times height and dividing by 2, you can just use this formula. Square root of 3
I see what it is.
divided by 4. What's S this time? What's the length of a side this time?
10.
10 squared. And you plug all that into your calculator. Just square root of 3, hit equals, divided by 4, hit equals. What is 10 squared? So times 100, that's going to tell you the area of that triangle. And we didn't have to know the height or the base of the triangle to find it. That only works if the triangle is equilateral. So there's just a whole lot of different formulas. I've given you a few here that you can use for all these different things. That's what we just talked about there. Circle, we talked about this earlier this year. Find this real quick. We're going to do circle and ellipse and we'll be done.
Okay.
What do you know about a radius of a circle? What is a radius?
Half, or
Goes from where?
The middle to the
Side to the
outside.
All right, goes from the center point to the edge. That's a radius. And Josie started to say that a radius is what?
The whole thing.
Half of a,
Circle.
Oh.
Half of what? Half of the circumference? Not circumference.
Half of the diameter.
there you go.
Can't
So-
believe you actually beat me to that. I'm so bad.
Half of the diameter is the radius, or 2 times the radius is the diameter. The formula for area of a circle is pi times radius squared. And I know I messed up now because this is the wrong PowerPoint. Because I also had circumference on here. Does anybody remember the formula for circumference of a circle?
No.
Hold on. It
It's
is-
pi times diameter, or diameter times pi,
Or it's 2 pi
or it's 2 times pi times the radius, not the radius squared, that's area. All right?
Oh.
And again, all these formulas that we're writing down, where are they at?
On the formulas page.
They're on this paper, so they're on there somewhere.
What about a circle's perimeter?
What is the perimeter of a circle? That's called the what?
Circumference?
That's the circumference, that's what we just wrote down here.
Oh, okay.
Yeah, that's what, I know I messed up and pulled up the wrong PowerPoint now because I remember switching, unless it just switched back. I remember putting all the circle on one slide and it's not on one slide this time. And the last thing, there's this perimeter.
Alright.
The last thing, an ellipse, not an oval, an ellipse. For area, an ellipse always has 2 radii. Has a short radii and a long radii. The radii, if I draw these whole things, they always bisect each other. They always bisect each other. So
How do you find the perimeter?
if this whole thing is 8, then that each part's 4. So that's for the area. The perimeter is that formula. It's a little tougher. Write it down real quick.
What packet?
Don't give us the packet. We don't have enough time.
That laugh was demonic, and I don't like you anymore, Branson.
No,
He said-
I started
No,
class,
it's
I was
tough.
thinking about not giving the packet. Then Branson fell asleep on me, and I thought I had to give the packet out.
Now everyone's gonna hate me. Thanks. Shut up, Cal. Shut up, Cal.
Packet's right here, grab it. There's like 38 problems on there. I probably don't expect that you're going to get every one of them done, but try to do as many as you can.
What about 18?
Try to do like a few of each shape. Don't just do the front page. Try to do a few of each shape.
You can do a few of anything else other than that. Come in and copy it down right, whatever it needs.
Make sure you grab the packet before you walk out.
You're so kind. I gave you an extra one. Have a great day, Mr.
You too.
It's not that's a dinner. I'm embarrassing to you. Get all over this.
Hey, do you remember what page that was?
What? 367, I think.
KOD, we got bad news.
What?
What the what?
Oh,
I did not remember that.